Welcome to another Refrigeration Mentor podcast in the CO2 Monday show. I'm your host, Trevor Matthews. Today, I got a great guest. Guy I actually met in person last year for the first time. We've been in conversation for a couple of years, just learning from each other and growing from each other. Really, me learning from Paul because this guy's a legend in the industry, and he's been in the industry for before I was even born. This guy's been doing refrigeration, and he's been crushing it day in, day out. He can outwork most of the young guys in the field, especially on CO2. And I'm excited to have this conversation with him. We're going to be diving into startup commissioning. And who knows where this conversation is going to go, because when we start getting into the conversation, it's wildfire. So, and I always love bouncing ideas off with Paul. And I'm excited for this conversation. Paul, welcome to CO2 Monday. How you doing, brother?
Welcome, Trevor. Thank you very much for having me on. It's been a year or two in the making.
Yeah. No, it's so hard. You're just always on the go. I like every day of the week I talk to you, or when I do talk to you, you're in a different state, you're in a different city, you're working with different technicians and contractors. And I don't know how you do it. You're working harder than I'm sure you did in your 20s these days.
Well, it's a pleasure because I enjoy going out and meeting new friends every week because basically that's what I do. And it's just great. I meet a new friend, seeing new contractors. It's the same rack, different issues. Yeah, I enjoy it. And that's why I'm still doing it and hope to be planning on doing it for a few more years.
Oh, I know you will be. I know you will be. So when we met, me, you, and Rusty had dinner last, I think earlier this year in June. Got some good conversation. You started off in refrigeration, actually in the Navy. Is that correct? Is that when you started?
Yeah, I joined the Navy directly out of high school, did 10 years, was a steam propulsion engineer first, 1,200-pound steam plants, and then I reenlisted for the HVACR school. And in 1983, I started doing refrigeration.
Awesome. You've seen the transition in all the different refrigerants. You were working with the R12s, the 502 way back then, and then you've seen the progression in refrigeration going in CFCs out now, HFCs, and then now we're seeing HFCs out now into more of the naturals and HFO. Talk about, I'd love to hear that kind of growth in yourself, because you were a technician in the field. Now you're working one of the leading manufacturers globally on doing startup field support, and really helping them understand CO2, because this is still new, only 10 years. You've been doing it for over 40 years, you know what I mean? So talk about the transition of your career from being, starting out in the installation and the service to where you are now working for a manufacturer.
Well, yeah, when I first got out and started doing refrigeration, there was two refrigerants. You carried 12 and 502 on your truck. They worked better than anything I've seen to date, with the exception of CO2. And yeah, it was easy back in that day. There was no carrying 30 bottles of different types for refrigeration, HVAC, it's medium temp. It's gotten crazy over the years. Everything's a transition refrigeration anymore. It'll last for 5 or 10 years, 15, and next thing you know, they're phasing it out and you're going into a different refrigerant. That's the good thing about CO2. CO2 is it's here to stay. It's been here since the turn of the century. It was a refrigerant. I've seen the conversions from, I did a couple with DuPont on Long Beach, California. We had a fish food plant that was 502, and they made an offer to go in and provide the refrigerants and the instrumentation to monitor it and change out food. We had 21,000 pounds of 502 for HP80. And I'll tell you, that was a disaster. If anybody remembers HP80, it didn't work out well. We ended up going with a 408 finally. But yeah, I've been here through all the transitions from when refrigerant was 25 cents a pound. Worked for Kramer Trenton, which was a manufacturer in Trenton, New Jersey. They were the hot gas defrost masters back in the day. Russell Coyle bought them out. I did a stint with Russell Coyle for a year and a half, and then went on, did some marine refrigeration, some ammonia work in California. Came back home, and I did contracting, did a little my own business for 5 or 6 years. Grew very tired of that, and went to work for one contractor for 15 years. And then an opportunity came up with Hillphoenix back in 2016, and I've been going since.
And so back in 2016, when you started on with the manufacturer, were you fully entrenched in CO2 at that point, or were you working? Because I know with Hill, there was, they got their second nature systems where it's a glycol, they got all their older synthetic systems. And then really the transition because I had Scott Martin on a few weeks ago, and go check that podcast out. But he was saying back in 2006 is that's when they were starting to do CO2. This is 10
Yeah.
years in. You start in 2016. Were you focused on CO2 at that point? Because I know now you're fully focused on CO2. Every job site CO2 for you now.
My first exposure to CO2 was February 2017.
Oh,
My
there
first
you
transcritical startup.
awesome.
I knew a little bit about the E2. I had to teach myself. I learned the CO2 equipment, and I did 2 or 3 startups with a couple of people. One of my best friends here today, Brett Cheshire, did my first 5 startups with him, and we've been going strong since. I
Yeah.
converted over to strictly CO2, and it's been about a year and a half, year and 3/4 now. And now I'm basically just fair for the rack.
Okay, let's talk about that because back in 2017, you've been doing refrigeration for years and years and years, but really, this is when you start to have to learn more on the control side. You're the guy now, right? In 2016, 2017, you're coming out and you're helping the contractors startup assist. You're not there to do the startup for these technicians, where I've seen a lot of technicians, that's what they think the manufacturer's all about. You come in and you do the startup. That's not the way it works out there. If you're a startup guy, they come in for a startup assist. They're there to guide you, to help teach you a little bit, but you do the startup. And this is something that I'm trying to get through to a lot of people. The manufacturers, they're just to assist you, kind of just to hold your hand if you're unsure about something, not to do the startup for you. You want to talk a little bit about that?
Oh yeah, you're completely right on that, Trevor. Now, back in the beginning, the first year, I did a lot because I needed to learn, but I had the contractor standing there with me, and I made sure he was learning everything that I was learning at the same time. Because literally, yes, we're there for support. If you have an issue with the rack, if you have parts you need to get ordered, or cases, we were there to take care of. But a lot of it seems like they're expecting us to do the startup, and that's not why we're there. It isn't, and I really can't do a lot with the system because then a lot of responsibility falls on the contractor, or I apologize, on the factory, and that's not our job. Our job is to support the contractor, help him with anything he needs.
Yeah, exactly. And so this is important to know because when you are working with these technicians, you're trying to build a relationship with them, but they do need to understand it's business as well, right? Because I know you're such a friendly guy, you want to help everyone out there, but they need to learn some of this too. Because back in 2017, when you did know the E2, you know what I mean? What did you do? How did you figure this out?
I got my hand on an E2 and I taught myself. Luckily, I had assistants where if I needed questions answered, I could call a buddy, and I knew somebody at Emerson. He's still
Yeah.
there today, and my best friend, and he would help me out with things I needed to know. But I had to teach myself, and me personally, I've always had a hunger for, if I've got to work on something, I need to know how the entire system works, because otherwise, how do I troubleshoot it going down the road?
Exactly. So, how was that learning curve for you? Because this anyone can learn this stuff. Like I do trainings all the time, and supermarket trainings, CO2 trainings on your equipment, lots of other manufacturers' equipment, and teaching a technician. And the information's out there. Like you guys have information out there. Emerson has, or Copeland has the information out there. Microthermal has the information. Corel has the information. But it takes work. What are some things that you could talk to or let technicians know on how they can start developing their controls acumen, I guess I could call it?
Most even ourselves, all of the manufacturers offer online classes or courses or books that you can get online and learn this equipment, from start A to B. Excuse me. And you're going to have to apply yourself. If you don't apply yourself, you're not going to learn. Me, I'm the guy standing over your shoulder asking you questions because I want to know.
Yeah. And that's important. And I really believe if we take more initiative in what we're learning, you're going to get better. That's why I'm so good at CO2, is because I'm diving into it, learning from it, finding out from you, asking other people. Not everybody is going to want to share their knowledge. They're not all like you, Paul, but there's a lot of people out there that want to. I see lots of people in the list and here who's hanging out here who are people who want to help others, right? And that are hanging out. So back in 2017, you learned E2, you start to learn CO2 on your own. What was some of the big learning curves or aha moments starting out learning CO2 for you?
Well, first thing is you got to figure out what's different from what your normal refrigeration system is. And basically that was just learning how the high pressure valve and the gas bypass valve worked. Because basically everything else is standard refrigeration. There's just, when I've taught classes, I've asked the guys, I want you to stop me during this process we're going through during the startup and tell me what you do different on an HFC system that I'm doing on the CO2. And rarely anybody says anything because it's all the same. Every part and piece has to be verified, make sure it's landed correctly. The programming is the manufacturer's responsibility. That's my job. And then how everything has got to work before you start putting gas in the system. It would be like buying a new car, not checking the oil, starting it up and driving off down the highway.
Exactly. So you've been to hundreds of startups now. What is one or two of the first things you notice with guys that are very new to CO2 who may have never even seen or heard of CO2 before, but heard about high pressures, explosions, fear of CO2? What are some of the things that you've been hearing and seeing out there from newer technicians getting into doing the startup with you?
A lot of them are definitely the first thing they're afraid of are the pressures. And I explain to them, there's so many safeties built into these systems that they don't have to worry about it. If we develop a high pressure, it's either going to shut itself down or we're going to vent to a relief valve. And everybody's scared of the relief valves. You can sit there and listen to relief valve pops all day because basically it's just like a drrr, off it goes. A little louder when it's the high pressure, but it's all it is. It vents, it reseats. CO2 is I like to say a violent refrigerant. Everything with that happens fast. It's not something that gradually builds up. It'll happen quick. So you need to have it performing properly before you starting it up, and you run into these issues with high pressure. I explained to them, guys, a lot of guys, we've got a term for it now. It's becoming industry known as CO2 stupid. That as soon as they walk onto a rack that says CO2 on it, they forget everything they remember and knew about refrigeration.
One of the things I do, and I don't know if you've done this yet, when I get to a site or I'm working with people or training people, and anybody can do this now, you all work with nitrogen, okay? Go over to your nitrogen bottle safely, turn it away from you, open it up, and you hear, shh. Well, that's what the relief's going to do. You know what I mean? It's probably louder. It's going to be louder with the nitrogen versus the CO2 pressure reliefs. And see it for yourself. Listen to it. So when it happens, you're still going to get a shock when you hear it happen. If it happened beside you, you don't think the relief's going to go off. But if you're watching the pressures as they start to go up, because I've done this before, I've seen the pressures go up on D2 and all of a sudden, oh my God, something better shut off. It doesn't shut off. And then the 1600 PSI relief opens up. Okay. It's a bit scary, but I watched it happen, because you're back away. But it's something that you're aware of. And after you, like I said, just open up a CO2 tank safely or a nitrogen tank, listen to it, spit out all that refrigerant. That's what it's going to sound like.
Yes. I can tell you in one startup, I lifted every relief valve on a rack as we were working on the control program for one of our new vendors, control supplies. And we were working through getting it to operate the system. And literally a minimum of 5 times on the discharge relief valve. But every other relief valve on that rack went multiple times. The only one that would probably scare anybody if it ever happens if you were standing in front of that compressor when that compressor 108 bar relief valve went, because when it goes up, it lifts forward and sprays back. And usually there's some oil coming with it. And that'll put a little fire in your butt.
Yeah. And this is why training's so important. So you understand where all the pressure reliefs are, even on those compressors. And you have to have a safety, like all our jobs or any jobs that you do, there's supposed to be a job hazard assessments. And I know a lot of guys aren't doing this stuff, but you need to go and understand what happens if that compressor opens up, and you're on startup now. So it opens up, you won't have maybe a full charge of gas. But if you come into a job site that's already a CO2 job site, and a compressor relief opens and it doesn't shut, you got to understand the safety procedures on how to isolate that compressor. You may need a Scotch pack in that facility if it's a big enough charge, and this is stuff that you need to take training. But it's no different than HFC, because if an HFC pressure relief broke or a discharge line broke or cracked or a head smashed and all of a sudden it's leaking into the mechanical, it is a similar thing that could happen.
As my friend Rusty Walker likes to say, R22 dead is the same as CO2 dead. If you're dead, you're dead. Yeah. And that's because you did something wrong.
No, exactly. Okay, so now you've been doing lots of startups with people all over the place, and I love it, from doing it with manufacturers, doing it from contractors. let's get into some of the startup and commissioning procedure that before you even get into it, that some tips for technicians that they should prepare before they get on the site. Because I know a lot of times you go to site and that site's not even ready for you. You flew out there for no reason at all because they're not even prepared or ready. Because this happens with all my manufacturers. Everybody, all my friends that I talk to at other manufacturers, same thing. They're like, I go to sites a lot of times and they're not even close to having me. What are some of the things that the technician can prepare for, as well as that job site can prepare for before you get to site?
I wrote a thing last year, and then we just went through it again. Actually, last month. It's interesting you brought this up on what we're going to require for the contractors to have it ready by the time we walk on site. Because if we're going to be there, especially if it's me, you get me for 1 week. Because the next week I'm scheduled to be somewhere else. So we're going to want to do everything we can possibly do and test while I'm there. And you need to have your comms need to be up and running. I've spent as many as 3 days helping contractors on a small Audi with 18 cases fix their Modbus issues because they weren't done and ready. You need to be that. You need to have your pressure test done. You need to have your vacuums and done. You need to be 150 psi charge on the system with oil in the reservoir. And the reason I say oil in the reservoir is because I want to fill the compressors from the reservoir, watch the oil circuit function and work, plus check the alarms prior to startup. I want to see the compressor cycle through all it's trying to fill with no oil going into it. And when it finally terminates on its 5th try, I want to see the alarms. Make sure everything's cutting off. It's part of verifying your control system's wired correctly.
Yeah.
Condensers need to be completely done. The insulation needs to be done. You know, you're working with, even though it's 515 psi, it's a 35-degree liquid. So your liquid lines are going to sweat. It's better to insulate them before than after. All peripherals done, the alarms, the klaxons for the walk-ins, and any alarm control panels need to be up and running. Everything's got to be done. The more that's done, the better startup we're going to have when I leave.
Okay. So this, and I know there's a few more things because I've talked to other manufacturers, but if you have this here, this is a good start. What are you walking into? And same as other manufacturers, what are you walking into most of the time? Like, because that's where they should be. What are you usually walking into, or a lot of the times walking into what is not done a lot of times? And you explain the comm issues, you know what I mean? 18 circuits of comm. But what are some of the things that you're getting into when you get to site, which is really slowing down the progress of this startup?
It's been, I got to say, the contractors over the past few years have been getting better, but we still walk into jobs they're starting to pull vacuums the day we show up. And I'm sorry, but if you're going to pull proper vacuums, you can't pull it on Monday and start on Tuesday, because that's a minimum 3-day job.
Yeah, and that's important.
Comms, I've walked up and not even had power pulled to the units. No control powers for the rack to run. Oh, it's been so many things.
Yeah.
Remember everything.
And this is not always the technicians' fault. Like Paul doesn't blame the technicians out there. This is sometimes the job is all of a sudden you get 2 weeks to do a startup, or here let's roll, get it all done. And it's like, what do you mean? 1 week to pipe 1,000 cases or whatever, you know what I mean? Like they don't give the technicians a long job. And so it's not, we're not saying that these are the technicians' fault. This is like the whole project's fault. A lot of the times, it could be end users, it could be contractor, it could be general laborers or general contractors themselves. But this stuff needs to be looked at before you're getting the manufacturer come to the site, because exactly what you said here, Paul, I talked to other manufacturers, the same thing. So when you do get to site, and you're on doing the commissioning and startup, what are the next steps that you're working with these technicians and things that they should be prepared for? So they did the comms, they did the pressure test, which was good. They did the evacuation. They got 150 psi of vapor in there, or 10 bar of vapor. What is the process next? And they checked some of the comms, and there's always going to be issues, things crossed over, and that's why you're there to help them notify this stuff. But what's the next step? And what, like day one, you're coming to start up with me. What would I expect in day one, day two?
When I walk on the site, the first thing I'm going to do is do a basic walk through the entire store And if the equipment's on the roof, walk the roof to see where everything stands as far as completion. First thing I do is after that is we're gonna go into the rack and we're gonna verify transducers. Make sure they're all correctly. Just because they're wired and reading doesn't mean they're landed correctly. I've done a couple of jobs where they've come out of our factory, and yeah, I know nobody's perfect, where the suction and the discharge have been reversed.
Yeah.
And we found that at startup. You got to verify transducers, verify your temp sensors,
Okay,
manually operate your fans.
Just before you go on to that, so what's the best way for them to do those verification? Just say for the temperature probe, what's the best way that you teach them how to verify each one?
Well, you can do either cold air or you can do with heat. Grab it with your palm if you don't have to cut the insulation. If it's insulated, it's easy to stick that can of air down in there and shoot liquid through into that insulation.
Okay,
and then
so
you look at it on your control monitor and watch the temperatures drop.
So like dust cleaner or something like that? Like
it's called canned air down here.
Canned air? Okay, yeah.
Yep.
And then you stick it in insulation and pull on it, and then someone's verifying it on either a tablet or back at the rack, and you let them know it's coming down.
That's correct.
Okay.
That's correct.
And then for pressure transducers, how would you verify for those ones?
Well, those are easy. We'll just pull them and watch them go to none. And when they go none, then you know you have the right transducer mounted to the correct input. And ours are kind of easy because the wires, say like wire 104, that would be board 1, input 4. So we make it easy to follow the channeling back. And another thing I like to do while we're looking at that transducers is we know we got 150 PSI in the system everywhere. Let's look at all the transducers on the rack and all the transducers in the cases and make sure we're reading 150 or a pound or two more. If we're not, we're going to need to investigate that before we start up.
Yeah. Okay, perfect. Perfect.
Yep.
So you get the temperature probes and you get the pressure probes. What's some of the next steps? Because you walk through the site now, right? You walk through the whole site. You looked at the rack. You looked at the gas cooler condenser. You check the temperature probes and the pressure transducer. What's some of the next steps?
So the next step I'll do is while I'm in the cases looking at transducers, I'll turn all the valves off because we don't want to start the system with the valves turned on. We'll want to verify them one at a time. When we're coming back on, we'll explain later. Well, we don't bring the whole system up at once because you could overpressurize the suction and pop a relief valve. So we'll get the transducers down. The case controllers need to be checked for the landing and the temp wirings too. Rusty has a nice little spill where you go in and you check them all with canned air. Same way. Some of the case controllers, like the Emerson case controllers, even Danfoss and Corel, they use wire colors. So it's good to determine where they're landed and they're landed properly.
Yeah.
Corel and Danfoss, you got to be aware of for walk-ins, they control off the discharge air. But on a walk-in, we always control off the return air. So either you move the sensor from the discharge to the return, so it's walking off the return, or you can go into the program with Danfoss and just zero out that S4, and then it'll automatically use S3, which will be your return.
So let's just say that one more time, because that was a really important point. You guys measure off the return for the case controller walk-in box. Is that correct? You just said?
The walk-in off the cases, we use the plenum return, the plenum supply temp sensor.
Okay.
We always use the discharge air in a walk-in in the cases. On the walk-ins, though, we use the return air sensor mounted right behind the evaporators.
Yep.
We're not gonna control off discharge.
That's right. And so what you need to do though is go into the controller and either switch that or move the sensor. Is that correct? Is that what you said?
Yeah, you can either move the sensor, but like in Danfoss, because I know I've been doing Danfoss startups the last 3 weeks, is you can go in and zero out the S4.
Okay.
It'll usually read 100%. You can zero that to 0, and the controller will automatically utilize S3 as the control point. You have to change your alarms and your display also.
Yep. Good, and that makes sense. And that's a sensor in the controller, the S4. So.
And the nice thing is with the Danfoss, the Corel, the Emerson CC200s, you can do that via Bluetooth.
Yeah, that's awesome. That's what's cool about technology. This is what I'm telling everybody. Like, technology and refrigeration is so much more fun now than it was 20 years ago.
Yes.
Because we got so many cool tools, and we'll talk about that in a little bit. But like now you don't have to walk 200 feet onto the roof, then 200 feet across the roof, when you can just look at what's going on the roof sometimes right from the palm of your hand or from the controller down below, which is so amazing. So
it is. One of the things I do to make it easier on my startups is I always carry with me a home router. and I set up a static IP in it, and I'll usually bring the controller up and put it on the network, and we can walk around wirelessly and do all our diagnostics and testing.
Yeah, I think I've met most of the control guys definitely know that. Like that's what they do. A lot of them, as well as definitely the manufacturers. I've seen countless times doing that with the team at Copeland. Set it up. So now that you did that, you know, you got the case controllers. You changed some of the sensors that had to be changed if you needed to. What are some of the next steps before we start getting into doing the startup?
Well, we'll need to verify our control circuits, our safety control circuits on our compressors are completed and made. We'll also want to test the high pressure switch. Unlike in the old days when we would just close off the discharge valve and let the pressure rise and pop the safety, today we'll just pull it off and check it. And we'll have to go by the verified 108 or 110 bar relief on our set point on that.
And then you would be doing that through using nitrogen. How would you be doing?
You just unscrew the power head assembly on the top and just literally disconnect it from the switch and it'll open.
Okay.
And then you can see that it functions. You test the oil by letting it run dry.
Yep.
In other words, before you put oil in the compressor, let it cycle like it's trying to fill, and that'll trip.
Yep.
Right. And then after the compressors, you'll want to make sure you have control of your condenser. Go into your AO and put a false signal on your condenser and step it up in 20, 50, 75, 100%. Make sure you control it all the way. Verify that you have your high pressure valve is working. Depending on the controller, you can manually manipulate it and you can hear it. There's no noise around. You can hear it open and close. You don't know if it's opening or closing, but you can hear it moving. Yeah. Same with your gas bypass valve, because these valves have to be functional when you turn the system on. And a lot of mistakes people make. And I had a guy call me today because he's starting up a rack and he's at 1400 PSI with and how he got two float bottles on his reservoir or float flash tank, I don't understand, because he should have tripped on high pressure long before that. But he actually filled it up and his high pressure valve's not working. So now he's stuck because now he's got to figure that out before he can get the system back up and running, which he'll probably end up venting most of that gas.
Yeah, because there is something that's in your manual where when you're doing a pump down, and I know this is more into commission because you have to do all these checks. You know, you need to pump it
Yep.
down. You gotta do emergency shutdown mode. There's a lot of other things that you need to do, but in your manual it says you pump it down. If you get it all the way up close to your flash gas line, you know, up over your two glasses, that's way too much. It's overcharged. You gotta isolate that line, and you gotta shut down certain compressors. And then you got to get rid of gas. And this is no different than anybody's rack. If it's overcharged, you got to get some CO2 out of the system.
Yep. Our gas bypass valve comes off a scoop that comes up and over at the top of the vessel or for our gas bypass relief. And if you get above that third sight glass, you stand a very good chance of pulling some liquid out of that vessel and into the compressors. So yeah, you got to be very careful. Our manual says when you're charging, you charge into the vessel. At the bottom of the vessel, we provide a fill valve. We don't charge in the liquid line. We don't charge in the suction line. We charge in the vessel, whether it's a startup or if it's top off. And we charge to the second sight glass. When you're at the second sight glass, you stop, and then you get your system ready to turn on. Then once you open up your liquid line valve and start bringing your cases on, if you're below your first sight glass, then you'll add a little extra to get it up to the first sight glass. Audis are easy because they're 7 to 8 bottles every day.
Yeah. And this comes in experience. And so when you're doing that, and you said it earlier, you're not just turning on all the medium temp all at once. You're staging on probably 25% or a few circuits, depending on how big they are. Do you go with the largest loads, say some walk-in box first, or do you do some like produce or meat? Like what do you like prefer starting up when you're doing you're starting to start the system up?
My preferred sequence is I like to bring on cases. Say like if you got 4 circuits, you got 50 circuits. Bring on 1 circuit of multi-decks. That way, if you have an issue, you can run into it. It's quick and easy to shut down. You're not bringing too much load on at a time. And then I'll bring that first one on and let it settle out and get the valves go to 100% after the 2.5 minute delay. And then I'll start bringing on more of it, more and more. I'm bringing up on a scale that I don't want to overwhelm the suction.
Yeah.
And we'll go over some of the other safeties we have for that when we have a shutdown. You got to have a minimum of 50% of your medium temp up and running before you ever bring on any of your low temp load. Me, usually, if it's a small startup, I bring on my medium temp all up online, all the cases, and then I'll start bringing up my low temp. And then usually once I get my low temp running, then I'll start bringing on my walk-ins. That's just my preference.
Yeah.
Everybody's got their own preference and how they do it.
And this is what I love about refrigeration. There's many ways to do refrigeration to get the same results. You got to just find a way that's the most efficient and effective and safe that you can do it, as well as anybody around you, but you can do it different ways. We're not saying this is the only way to do it. It's what your preference is, but when you can find the ways that make it easiest for you and you knock it out the park each time, that's it. It doesn't matter if it takes you a little longer than the next guy, but if you do it right the first time, that's what we're looking for. Getting it up and running right the first time, not 3 months down the road and that system's still not running properly.
Yep. Nope. Everybody will come up with, everybody will develop their own startup procedures, but there's a basic set of rules that you have to follow.
Exactly. Kind of like you talked about first, you got to make sure all your pressure tests is done, all your evacuation's done, installation's done. This is no different than any other refrigeration system when you're doing all this installation and startup. There are some differences with piping. Don't get me wrong. We talk about this many, many times. It could be stainless steel. It could be high pressure copper. You need to make sure you use the right copper in the right lines, because if it's a low pressure section, you need to make sure that you're using the proper copper. If it's high pressure copper, you cannot be using K copper going out to your gas cooler. You need to be using stainless steel or high pressure copper. I've seen this and heard this of times before, and I'm sure you've seen it when you go to a site and all of a sudden you're looking around for making sure all the pipe is correct. It says it right on those legends that you get from the manufacturer. It doesn't matter the manufacturer. They say, this is stainless steel, schedule what? This is our high pressure copper or K copper or whatever. If you're not following those, you can run into a massive issue, and the manufacturer will not do a startup with you if it's wrong. Have you ever come across that in the field before, Paul?
Oh, many times. I carry, Streamline gave out these nice little magnets at a couple shows. They're the rare earth magnets on a little Streamline tag, and they're great. I just walk around with them, and I'll on a contractor pipe system, I will walk around and check.
Yeah.
Just to make sure. And say 2 months ago, we had a contractor in Texas had to repipe his whole discharge system because he used K copper.
Yeah. And I've heard about this before too with other manufacturers, and I don't blame the technicians too, because they probably didn't know. And I've been on lots of installation jobs, and they should send you a big tractor trailer of pipe. That's it. Here's a big pipe. So just go here. It's 2 and 1. It's 1 and 5. And if you didn't have any training on it, you don't know, right? This is why you need to get CO2 training. You got to come to Refrigeration Mentor and get some training. But this is important. And I heard other manufacturers tell me the same thing. I get there and it's K copper going out to the roof. It has to be repiped. So just remember that there's different pipes for different pressure section of rack. Okay, so you get 50% up or you get 100% depending on the size, and you get your low temp up and running. So what are some of the next steps before we get into some of these pictures that you sent me?
Let's walk through it completely. The first thing I do before I open up the liquid line from the vessel, once we have a full charge, actually backing up, before we start to charge the vessel, we switch the receiver relief valves from our 45 bar to our 60 bar position. That gives us a lot more pressure to work with while we're charging the system or doing maintenance. All right. And we'll go over 45 bar. The reason why we have a 45 to 60 bar as we get to the cases and piping downstairs. But yeah, we're going to switch that. Then we're going to go ahead, and during the charging procedures, we've already seen the high pressure valve and the gas bypass work, and we've also seen the condenser work. So we know we're good there. We've already seen everything on the rack work. The compressors come on, so we're good to go. So now we've already shut off all of our valve controllers down in the store. So we're going to open up our liquid line. We get the liquid line open, and then we're going to start picking what cases we want to turn on. So we'll go into the controller, we'll turn on our cases, start to get the system to come up and running.
So Paul, for the case controllers, are you just turning off the circuit at the controller at the rack? So you're on the E2 or microthermal, Corel, whoever, and you're just turning all those circuits off at the rack, like the controllers. Is that correct?
With Danfoss and Emerson, yes.
Okay.
With Corel, we have to go down to the rack itself and turn, or I apologize, the cases themselves and turn them off right locally.
Okay. So
all right.
Locally, Danfoss, E2 microthermal, be remote, like at the
remote, yes.
Yep. Okay, perfect.
And it's So with Danfoss, you just turn the start stop to stop. With Emerson, you just go ahead and turn the valve percentage off. 101 automatic to 0. So we'll start bringing our cases on, and we'll want to watch them come up. We'll want to watch the superheat, make sure the superheat's not getting too low, because when the super case gets low, it's going to start coming back too low. All right. So we need to be cognizant of that issue. Then we'll bring all our cases on. We'll get everything running. Once we're up and running, then we'll start to actually go through and look at the tuning of the rack. How our high pressure valves operating, is the gas bypass holding pressure? Is our superheat staying where we want it for our low temp and our medium temp circuit? We're going to switch the valve from 60 bar to 45 bar. The reason we switched to 45 bar is because and going back to piping, you got to make sure when you pipe your low pressure pipe setting, you're using the proper pipe also. Usually K, and if it's L, some of the smaller sizes, you can get away with it, because our relief valve at 45 bar is 652.
Yep.
Our burst pressure for our pipe and our coils is 700, I want to say.
Yep.
That's one of the reasons why we don't charge into the liquid lines, because if somebody's got something locked up and you're charging liquid into it, and the liquid line valve's closed on the vessel, and no way for that pressure to back feed into the vessel, you could blow a liquid line apart.
Yep, exactly. And now you know where your refrigerant is. And I learned this from the guys from Advancer in Europe. They were like, Trevor, you always want to know where your refrigerant is in a CO2 system. So I know here a lot of times, and when you're doing a maintenance, and we'll get into that in a little bit, where people, like in some of your systems, you can isolate one oil separator and then you can work on another, isolate one, another one's running. Where I know Advancer guys, they love if you just pump down the rack, and then you can work, you know where all the refrigerant is in case something happens. You know what I mean? All the refrigerant in your receiver, in your flash tank. Where if the whole system's running and then you have something happen and you're working on the system right here and you're like, what's going on? Then you don't really know where all the refrigerant is. So it's always.
And I agree with that. Yes. Yep. Know where it's at, and then you know where your problem's going to be.
Yeah, exactly. So then you start charging, you get the receiver to where you want it, then you open your liquid. And then now we're up and running. You got a bunch of circuits running. You watch the superheat coming down. You're making sure the compressors aren't flooding back, low temp or medium temp. They're working. What are some of the other things that you want to look for? Because now superheat's working okay, or not even superheat. Do you guys use temperature? Do you ask them to use case controller temperature with superheat, or how do you guys do that, or how do you want the contract? Because it is up to the contractor, I think. But what way would you like the controllers to be controlling the cases? Do you use temperature? Do you use superheat? Use temperature and superheat depending on the control manufacturer?
That's the whole thing. It's all dependent on the control manufacturer. With Emerson, you're going to control the superheat till you get down to you're going to control the superheat till you get to temp. Once you get to temp, then it's going to sacrifice superheat over case control. So then your superheat might go high. And with these Danfoss or Sporlan pulse valves and Emerson pulse valves, you're not going to set it at 10 degrees. It's going to hold 10 degrees like an old mechanical expansion valve does. It's going to be, I call it the flash flood system. We flash liquid in there and we flood liquid in there and flash it off. Yeah. So your superheat's going to modulate all the time. If your case is making temp, it's not a big issue. If you see 20 degrees superheat. Now, if you start seeing 30 or 50, then you need to look at it.
But the big thing is though, most of these cases that you guys design aren't even 10 degrees superheat. You could be 7, it could be 6, it could, you know what I mean? So depending on the case, because you got to take all the things that you've learned, these rule of thumbs, because refrigeration is a science. You know, those coils could be designed for a lower superheat. I see everyone putting 10 degrees superheat. Do you recommend 10 degrees superheat for every case and coil?
Yeah, I was just going to get into that. Us as a manufacturer, we recommend for steppers, our pulse valves, 10 degrees.
Okay.
If you start trying to control 6 degrees, like, you know, our case settings, they come with a set of instructions, and those settings will say 4 to 6 degrees superheat, 6 to 8 degrees superheat. Those are all actually for mechanical HFC systems, mechanical TXV HFC systems. When it comes to the stepper valves, we're across the board at 10 degrees.
Oh, are you? Okay, good.
We've seen where when we go lower, we usually end up flooding back.
Okay, so you guys do have systems though that you run lower superheats. Are you? Because I know I was talking with Scott about it. Maybe you don't have many of those out there yet, but you're running lower superheats on those more of a flooded system.
Yeah, Advancer has the new low superheat control system, which we don't have here in the U.S. yet.
Okay.
We do have our flooded cascade systems where we're running lower superheat.
Okay.
But transcritical, we're running a 10-degree superheat.
Perfect. Good to know. So you're running that superheat there. You're running, like we said, depending on the controller, it could be temperature, then superheat, depending on the control manufacturer. And then you check that, and that's running good. What's the next steps then? And you get the
well,
high.
Then you're going to go back and you're going to start diagnosing any issues you find where maybe a temp sensor's reading wrong, or you had a good pressure reading on the transducer, but all of a sudden it blanks out on you when it hits 200 psi because it's the wrong transducer.
Yeah. And the big thing is too, is that, and we got some pictures here that we're going to show everyone, is that drop leg sensor for your high pressure valve is like one of the most important sensors. And that pressure, the gas cooler pressure transducer and the flash tank receiver pressure transducer are so important.
They are. If you have to pay attention and make sure you do something exactly right, those are the ones you're going to want to concentrate on. The drop leg is really specific.
So you get it up and running, you get any bugs, if there's like a case control is not working properly, the oil's not, they say the oil's not filling properly, all these things you got to be checking even maybe before you do the startup. But you get the startup and running, some things that you didn't notice before that, that first commissioning phase. Now you got refrigerant, you might get something that happens, so you'll sort that out. What is the next step? So you said checking the safeties. That's an important one. So you check the high pressure safeties. You want to check all the safeties. What happens in a emergency situation? Because someone had a question here, like initial charge, and if there's an emergency situation where the rack lost the charge and the CO2 starts to warm up in the cases, what procedures do you follow? So emergency shutdown.
This is something that I came up with on when we've had a few emergencies and I've been brought into. I have had the fortunate opportunity to talk with contractors all over the country. These guys call me when they're in trouble, I guess because I answer my phone and I walk them through what's going on. But one of the things that came up with on site was, say if you got a rack, you broke a discharge line, you just dumped the entire charge. So you fix your unit, you get it running. If it's an 8-bottle charge, I say get 4 bottles in the vessel. Now, the nice thing about that job was it was XM 679s. So we could go into the controller and put the max operating percentage of 50% on the valve, not allowed to go above 50%. Get 4 bottles in, open up the liquid line, and get that system start to working. Manager's going to get a warm, fuzzy feeling because his cases are starting to come down in temp. But at the same time, you're still charging into the vessel, getting the rack up and running. And it's a good way to you can charge into the vessel as you're still running the system. That pressure is going to be 515 psi above and below set point, no matter what. Charge into the vessel until you get a full charge up. We've done that. You can get 4 bottles in the system in about 15 minutes, 20 minutes, and then get it back up and running. Then you're going to start cooling your product down right away. CO2, the ability for it to pull heat out of those cases is 4 times better than the regular refrigerants. It happens fast. So yeah, the manager of the store will start feeling better because the system starts to cooling, and you'll be back up online running and getting the system fully charged.